Are you working with the CANape option driver assistance and looking to fully understand which sources are available in the GFX configuration? Stay tuned to learn it all in no time. Hello and welcome. My name is Katharina and I will give you an overview of all the sources available in the GFX configuration. Please be aware that the features shown are only available with the CANape option driver assistance license. First, I will provide an overview of the various types of sensor data, and then we will take a closer look into the signal object adapter. A sensor can provide data in different formats, such as protobuf, CDR used in DDS, flat buffers, or structured data from some IP messages, which are supported by the GFX configuration. When the sensor detects a defined object or structured data types, a corresponding GFX object can be created directly from them. You ask yourself which sensor types are already supported in CANape? Have a look at our website linked in the description to find out. If the database only contains scalar signals, there are two options depending on your use case. Let's say we want to change the signal value using a calculation first. We can modify the value using a castle function and hand the value over to an output parameter. If we use the output parameter as a result, it can be mapped as a source in the GFX configuration. This is also possible with CRT functions. The second option is to use the scalar signals in the GFX configuration without modifying them, which is no problem. We can simply create a signal-based object from them. But how does this work? Signal-based objects are created with the signal object adapter, either online or offline. The signal object adapter is used to combine individual scalar signals into a logical data packet, for example, an object or a list of objects. We can open the online signal object adapter in the measurement configuration by right-clicking and choosing Insert Signal-Based Object. To open the offline signal object adapter, we go to the menu bar and select ADAS, Signal Object Adapter Offline. When the signal object adapter is open, you can see that it has three main parts. The object type is defined in the target part of the selection. By default, the signal object adapter provides a position object for out-of-the-box geographical position display in the map window. We can define custom types, including subproperties of different data types. In this case, we'll define a detection with the properties ID, bright lights, length, position in X direction, position in Y direction, and so on. By clicking OK, we define our custom target type. The second section in the middle of the window is the assignments part. Here we can create new objects by dragging and dropping the target into the assignment section. If you use the signal object adapter offline from a file, it's important to know the difference between virtual and non-virtual objects. The virtual mode is the default option, in which the objects are calculated virtually on demand when the measurement cursor is moved. In the non-virtual mode, the objects are calculated all together and saved in an additional measurement file with the postfix name objects.mf4. This mode is used to support older measurement projects or in cases where computing the signal-based objects is time-consuming due to the number of input signals. Every signal-based object needs a suitable converter, which contains the information how objects are created. We can find out which converter to use in the tooltips when hovering over the text. For our detection signal-based object, we choose the sequence converter. In the Properties section, we can either drag and drop signal values from the source area to the properties or enter fixed values directly to the field. Once the assignment is complete, we can close the signal object adapter by pressing OK. The next time we start the measurement or do an offline evaluation, the signal-based objects will be created and made available as a source in the GFX configuration. We want to see our objects during the measurement and afterwards using a recorded MF4 file? No problem. All we need to do is load an MF4 file after the measurement into our project and select Show Values for Measurement file. The configuration is then applied to this file, which means that the objects of the configuration are now displayed with the data of the new loaded measurement file. This applies to all files measured with this project, or with the same signal structure. That's it. We can now analyze the objects from our measurement file quickly and easily. That's everything you need to know about the different sources in the GFX configuration. I hope you found this video helpful. Feel free to contact us, and thanks for watching. Do you want to learn more about the CANape Option Driver Assistance? We've got you covered. Check out the rest of our tutorials and don't forget to like, subscribe and turn on the notifications so you won't miss any new videos. See you.